talk about deciphering, and deciphering is the process of recovering the original message from an enciphered message. From the previous recording, you've seen that an affine cipher is basically an algorithm that is used to transform a sensitive message, and it uses some theory of linear congruences. When we look at the deciphering rule for affine ciphers, we see that the rule D for deciphering the affine cipher EX congruent AX plus B modulo 26 is given by dy congruent V into Y minus B modulo 26, where V is any multiplicative inverse of a modulo 26. When we look at the terminology of sets and functions, we see that E is a one-to-one function and D is the inverse of function E. We'll use this table to find we'll use this table for the conversion of letters and numbers. So these are alphabet letters and they're represented with integers 0 to 25. So when we look at an example, that is activity 38, suppose you receive the following two messages that have been enciphered using the specified affine cipher A. What do the messages say? The first example is 14, 10, 6, 22, and 22 using the affine cipher EX congruent 5x plus 10 modulo 26. So the solution is a rule D for deciphering the message is given by dy congruent V y minus 10 modulo 26, where V is a multiplicative inverse of 5 modulo 26. So first, we need to find the multiplicative inverse of 5 modulo 26. And here we'll apply Euclid's algorithm and backward substitution. So the Euclid's algorithm, when you write it as an equation, it gives 26 equals to 5 times 5 plus 1. 1 is the remainder. And 5 is the quotient. So a remainder 1 is obtained, as you can see here. So 5 and 26 are co-prime, and thus 5 has a multiplicative inverse modulo 26. So we need to first rearrange the equation with the remainder being on the left side. So that is 1 equals to 26 minus 5 times 5. Now we'll apply backward substitution, whereby you can find V and W integers such that 26V plus 5W equals to 1. So you can see that it will be 1 times 26 minus 5 times 5 equals to 1. So negative 5 here times 5, you get that it's congruent to 1 modulo 26. So from that, we can see that negative 5 is a multiplicative inverse of 5 modulo 26. So moving on, we see that from the rule dy congruent negative 5 into y minus 10 modulo 26, now we'll use the deciphering rule to decipher the message. So D14 so 14 was the first number from our question. So we'll start with 14 and equate it to the deciphering rule. What is basically these integers that we are given here to solve? So we'll start with D14. It's congruent to negative 5. Y is 14 minus 10 congruent negative. Okay, when you do that, you get negative 20, then which is congruent to 6. modulo 26, and the next integer was 10, and so we equate it to the deciphering rule. Yeah, you get that, and also equate 6 and 22. So you get that the deciphered message is, it's 6 representing 14, and 0 representing 10, 20 representing 6, 18 representing 22, and the last one was also 22, so we don't need to calculate again, and we get it's 22. So when we use table 1, so we need to look at these integers and what letter they represent. So like 6, you can see 6 is G, then A is 0, then U, we can see that it's 20, and 18 is S, and the last 18 also is S. So the message that we get is Gauss. Moving on to the next question. So these are the integers you're given, that is 22, 8, 11, 22, and 9. And using the affine cipher EX congruent negative 9x plus 6 modulo 26. So you start by writing the rule D for deciphering the message, and it's given by dy congruent V into y minus 6. You can see 6, it's gotten from here, modulo 26, where multiplicative inverse of negative 9 modulo 26, and we'll apply Euclid's algorithm and backward substitution for that. So Euclid's algorithm gives 26 equals to, so we are finding a number that when you multiply with 3 and if there's a remainder, it will give us 26. So that is 3 to give us negative 27. Then when you add a remainder 1, you get 26. So then you take this to be on the left side. Then you take this to be here. Then times negative 9. You get that the remainder is 0. So when you get that the second last remainder is 1, then basically the two integers, that is negative 9 and 26, are coprime, and negative 9 has a multiplicative inverse modulo 26. So you first rearrange the equation. It will give us 1. So you start with the remainder being on the left side. So it's 1 equals to 26 minus 3 times negative 9. And backward substitution helps us to find VW such that 26V plus negative 9W equals to 1. So we can see that negative 1. Okay, what number when you multiply it with negative 1, then minus 3 times negative 9, it will give us 1. So it's negative 1. So when you write it as a congruent modulo 26, you get that negative 3 times negative 9 congruent 1 modulo 26, and you get that this negative 3 here is the multiplicative inverse of negative 9 modulo 26. So from the deciphering rule, dy congruent negative 3 y minus 6 modulo 26 we'll use this rule to decipher the message. So we'll start with the first integer, it was 22, and when you equate it to this equation, this y is these integers are given here. You get d into 22 congruent -3, 22, that is y minus 6, or it's congruent -48 for modulo 26. Same to 8, 11, 22, and 9. You do it like this, and you get the deciphered message is 4, 20, 11. These numbers here, and 4 and another 17. So when you use table 1, that was our conversation table for letters and numbers, we can say that 4 from the table is letter E, and 20 is letter U, then 11 is letter L, and 4 is E, and the last one is 17 is letter R. So by using that table, we can see that the message was EULA. Thank you.